Hey, everyone. It's Miss McMillan, and today we are going to talk about fractions. And we're going to do that by first talking about parts of a fraction. And we're going to do that using the example 1/2. A fraction is made up of a numerator and a denominator. And we're going to take a look at each piece of the fraction today. The numerator is the number on top, which tells us the number of pieces being counted or the number of pieces that are shaded. The denominator, on the other hand, tells us the number of total pieces in the entire whole. So again, the numerator is the number on top that tells us the number of pieces being counted, and the denominator is the number on the bottom, which tells us the total pieces in the whole. Now we're going to take a look at some models using a fraction strip. So, as you can see, my denominator is 2, so that tells me the total pieces are 2, which is why I split that fraction model into 2 equal pieces. My numerator now tells me how many pieces are being counted. So I am going to only shade in one of the 2 pieces to represent how many is being counted. Now let's take a look at another example using a circle model. Again, I'm going to split it into 4 equal pieces. Then that's going to tell me the denominator is going to be 4 because there's 4 pieces in the whole. And then I am going to put 2 as the numerator because there are 2 pieces being counted or 2 shaded. Now let's talk about fraction as a whole. A fraction as a whole is when all of the pieces are there or when all of the pieces are being counted or shaded. So let's take a look at these examples. I'm going to draw 3 fraction strips and I'm going to separate them into equal pieces to demonstrate all of the pieces being counted, which represents the entire whole fraction being counted or shaded, which means one whole. So as you can see from the first model, there are 4 equal pieces. The second model shows 5 equal pieces, and the third model shows 2 equal pieces. With the first model, I'm going to shade all of the pieces, which is going to represent that all of the pieces are being counted or all of the pieces are shaded, which means the entire whole is being represented, shaded, or counted. So that would be 4 over 4 and 5 over 5 and 2 over 2 because we are counting the entire whole, which would equal one whole. So when all of the pieces are being counted or when all of the pieces are shaded, it would represent one whole. Now let's talk about unit fractions. Unit fractions are each individual pieces in the whole. So for example, if I have this fraction strip and I separate this fraction strip into two pieces, that tells me the denominator is going to be 2 because I divided that into two equal pieces, which means the unit fraction is going to be each individual piece, which would be 1/2 and 1/2. And since I have shaded one of those half, the fraction would be 1/2. Again, with this example, I am going to separate this into three equal pieces. And because it's separated into three equal pieces, I automatically know that the unit fraction is going to be 1/3 of each of those pieces. And again, if I were to shade one of those three pieces, the fraction would then be 1/3. Another example here, I'm drawing another fraction strip. I'm splitting it into four equal pieces. So that lets me know my denominator is going to be 4. And that lets me know my unit fraction is going to be 1/4 because there's going to be four equal pieces. Now let's take a look at fractions on a number line. So let's draw a fraction on a number line. So you do this by basically drawing a number line, and you're going to label from 0 to 1. After which, I'm just going to go ahead and divide my fraction number line into equal pieces. Now, just looking at that, I'm going to have to figure out how do I create a fraction just by looking at the fraction on the number line. So here we have to take a look at the fraction on the number line. We have to draw a model, and we also have to identify where it is plotted. First thing we want to do is determine what the denominator is going to be. And we do that by looking at the space from 0 to 1. And that's how we're going to determine what the denominator is going to be. So the spaces from 0 to 1, we determine is going to be 4. So that is what the denominator is going to be. Now we figure out what the numerator is going to be by counting our spaces from 0 to that plotted dot sign. And we figured out it's 3. Then we draw our model. We determine that the denominator is 4. So we split our model into 4 equal pieces. And then our plot dot stops at 3. So we're going to shade in 3 of those 4 pieces that are being counted. Let's take a look at some more example. Now, if you take a look at the first model, again, count your spaces from 0 to 1 to determine what your denominator is going to be. And we determined that the denominator for the first example is going to be 3. And I should have made a plot dot somewhere there, but I did not. Again, the second example, let's determine what our denominator is going to be. We count the spaces from 0 to 1 to determine what our denominator is going to be. And we realize that our denominator is 8. And I forgot to put a plot there. Now let's take a look at some fractions greater than 1. And fractions greater than 1, in simpler terms, are when the numerator is greater than the denominator. And I'm going to show you some examples on how that happens. Again, let's take a look at a fraction on a number line, or just a number line by itself. So again, if we take a look at this number line, we notice that this number line goes beyond 1 because it's going to represent a fraction greater than 1. So when we are looking at fractions greater than 1, the first thing we need to do is determine what the denominator will be. And we determine what the denominator will be by looking at the spaces from 0 to 1, or the jumps from 0 to 1, to determine what the denominator will be. In this example, if we count the spaces from 0 to 1, or we count the jumps from 0 to 1, we can determine that the denominator is going to be 4. But we still have to figure out what the numerator is going to be. And we figured that out by counting the space from 0 all the way to that dot that's plotted on the number line to determine what the numerator is going to be. Let's take a look at another example showing fractions greater than 1. Again, the first thing we're going to do is determine what the denominator is going to be by looking at the spaces from 0 to 1. So we're going to count those spaces, and we're going to realize that the space from 0 to 1 for this particular example is going to be 4. So our denominator is going to be 4. And then we're going to continue counting on to realize that our numerator will now be 6. Now that we've determined what our fraction on the number line is, now we need to model. Again, because our denominator is 4, we are going to split our model into 4 equal pieces. But our numerator is 6. So guess what? We have to draw another model because it is a fraction greater than 1. Split that also into 4 equal pieces, and that's when we are able to shade in 6 of those pieces to represent 6 over 4, or 6/4. Now we have an example of a fraction on a number line as well as the model.